incredible partnership between the Kinect team and Microsoft Research has allowed us to make tomorrow happen today.
The feedback that we've got from users about PhotoFuse has been amazing, and we know we couldn't have brought this feature to our users without the collaboration with Microsoft Research.
What's fun about Microsoft Research is that we're constantly exploring, looking for the best ideas. We're taking things that people thought were improbable and making them possible, and then taking them all the way to reality. Well, hello, everyone. I was kind of waiting for the voice of God, but I guess we didn't have a voice of God today. My name is Rashid. I run Microsoft Research. Back in September of 1991, when I came to Microsoft to start Microsoft Research, I developed a mission statement for the organization that's really stood the test of time. And we continue to use exactly the same mission statement today that we created back then. The first part of our mission statement is to move forward the state-of-the-art in the areas that we do research. It says nothing about Microsoft. It really just says we're going to do fundamental basic research. We're going to move the state-of-the-art forward in the key areas that we do our research in. The second part of our mission statement talks about how we take advantage of the work that we do in our basic research activities. And that part says when we have great ideas, when we have technologies that make sense, we work as hard as we can with our product organizations to move those technologies into use, to make those technologies available to the public. Ultimately, both that first and second part relate to what's always called the third part of the mission statement, but really it's just a summary of the first two. And that is, our goal is to make sure that Microsoft and its products, and really the field of computer science, continues to have a future. Now, the first part we've been extremely successful with over the years. If you go to any major conference in an area that we do our research in, you'll see an enormous number of papers from Microsoft Research. In many fields, we're really helping to move that state-of-the-art forward in a way that no other industrial research organization really has done historically in the field of computer science. Typically, today, you'll see anywhere between 10, 15, 20, sometimes even 30, 35% of all the papers in these major conferences come from authors that are from Microsoft Research. So we've been extremely successful in that part of it. Now, TechFest, which is the event today that you're all here for, it really relates to the second part of our mission statement. It's really one of the things that we do to help move technologies rapidly from our ideas and from the research that we're doing into use, into our products. Now, historically, this is I think the 11th year we've done TechFest. I think the very first TechFest was 2001, so this is the 11th TechFest. And you could ask yourself the question, well, why didn't you do TechFest before that? Historically, we didn't do anything like this. It's only really been in the last 10 years that we've been doing it. Well, in the early days, Microsoft Research and Microsoft were pretty small. It wasn't that difficult for researchers to simply walk down a hallway and interact with developers and the various product teams. When I first got to Microsoft, there were just a few thousand employees. Many product groups had less than 50 people in them. Really wasn't that difficult to interact. Plus, we didn't have that many researchers. It wasn't until, I think, 5 years into the creation of Microsoft Research in 1996 that we actually reached 100 researchers. So we were small. The company was small. There probably wasn't as strong a reason to do something like this. As the years went on, though, and as both organizations grew, it became important for us to find new ways to communicate with the large group of Microsoft employees. And interestingly enough, I was probably the least excited about doing this kind of technology event in the organization, because I mean, several years before we started the first TechFest, our group of program managers and some of our researchers would come to me and say, hey, I think we really should do some kind of a technology fair. And I would say, boy, that sounds like a lot of work. I'm not really sure it's going to make any sense. I mean, why can't people just talk to each other? I didn't really quite get it. Finally, they convinced me. And when we had our first TechFest, it was just an amazing success. It really blew everybody away. I think the very first year we had TechFest, we had over 4,000 employees for the Puget Sound area come for that event. At the time, that represented 20% of all the employees that Microsoft had in the Puget Sound area at the event. And the feedback we got, not just from the employees who were incredibly excited about the technologies they saw and had an incredibly good time interacting and learning from our researchers, but the researcher reaction was even stronger. They had such a good time talking about their work, interacting with the people in the product organizations, learning what they were doing, as well as showing off the work that they had done in research, that they were really excited about doing the event again. And then when we looked at the follow-up, and we do a huge amount of follow-up for our TechFest event, that was even more impressive. So many opportunities were created, really serendipitous opportunities, by having our researchers and just anyone from the product organization be able to come and interact with them. That created relationships, it created opportunities, it created situations where ideas made it into products that would never have happened any other way. And so that really convinced us that this was something we needed to do on an annual basis. And today, this, as I said, this is now the 11th time that we've done TechFest, and each year it's grown. Each year the opportunities that have been created by TechFest have grown, and each year, we feel like this is a huge opportunity for us to be able to move our ideas and our technologies into our products. Now, when you think about technology transfer, a lot of times people think about technology transfer as some kind of a directed activity. The people will ask me, gosh, how is it that you decide, what ideas make it into your products, or how do you manage that activity? How do you pick the research areas and things of that sort? And the answer is technology transfer really isn't about technology. It's really about people. That's why events like this are so important. Technology transfer is about getting people to know each other, to learn about each other's work, to trust each other, and to build those human relationships that allow ideas to flow from research, into product and into use. And those human relationships are an incredibly important part of the whole technology transfer process. In fact, we have a team. In fact, this is part of the team that puts a TechFest together every year. A team of program managers whose sole job it is really to help move ideas from research, into our product team. It was something that I created really originally with a single individual back when I started Microsoft Research, feeling that it was important to have humans really being the middle, sort of the glue that held researchers and the product organizations together. And we've grown that program management team over the years. And really, they act as the sort of the dating service. They arrange the marriages. They manage the wedding and the wedding reception. And if necessary, they do marriage counseling and child support services afterwards. Just to make sure that those human relationships are maintained, are developed, and are really prosperous for everyone. Now, this has been, I think, a particularly good year for Microsoft Research in the sense of many of the technologies that we've been developing, many of the ideas we've been working on over the last few years have really been seeing coming to light, really coming to fruition over this last year. It was interesting that I was in Silicon Valley for the opening of the Computer History Museum's Revolutions exhibit. And if you haven't, by the way, gone there since they opened that exhibit, I would recommend it. It's an incredible exhibit that they've done. And I was there for the sort of the launch of the exhibit and the reception that went with it. And there was a journalist that came up to me that I'd known for several years, and he said, you should be, I'm sure you're really happy right now. You should be really proud of the fact that so many of the things that you guys have been working on for years, have really had a huge impact in the last year. We talked about Kinect. We talked about the work that's gone on into Bing and the impact that that's been having. We talked about things like PhotoFuse that you saw in the video, the touch mouse, and so forth. And so he was saying, there's so many things Microsoft Research has been doing that's now having an impact. That should make you feel particularly happy and particularly excited. And it was interesting because certainly I was very happy about that, but it also struck me that that in a way I didn't really think of this year as being that different than previous years. That in a sense, part of what he was seeing was the fact that many of these technologies are coming out in very consumer-oriented or customer-facing, end-user-facing products, but that in fact, if you go back through the history of Microsoft Research and the history of the company, we really have had an enormous impact every year. Many years it's in creating products that are more for a business type environment. I think there's a slide that shows off just very small fraction of the products and the technologies that we've been bringing to market over the last 10, 15, 20 years. So if you go back historically, one of the first early very important impacts of Microsoft Research was in creating a technology that dramatically reduced the working set size of 32-bit applications and programs, and allowed Microsoft to simultaneously ship Windows 95 and Office 95 together. Now, again, that's not something people would normally think of as, wow, this is some incredible thing Microsoft Research did. But it was actually an incredible technology that gave Microsoft an enormous advantage in the marketplace at a critical point in time, and allowed us to have an amazing launch of Windows 95, which was enormously important for the company. So many of the technologies we've created over the years have allowed us to go into new businesses or to create new businesses. For example, a lot of the work we did in 3D computer graphics in the early days, in the early 90s, mid-90s, became a critical part of our DirectX technologies for Windows. And then those led inevitably to the ability that Microsoft had to enter into the game console business and to create what is now today the #1 game console system and the #1 online gaming system. So those are examples, but they're just even a few examples of the things that we've done. Over the last decade, 10 years or so, Microsoft has created, 8 major businesses, with Kinect now 9 major billion-dollar businesses, new billion-dollar businesses. And in many cases, it's been the technologies from Microsoft Research that have allowed us to do that, whether it was the technologies from research that allowed us to go into the internet search business, be competitive rapidly, and then to bring our product to the point where it is challenging the leader in that space, whether it's the technologies that have allowed us to dramatically impact the work that we're doing with things like SharePoint, which is a multi-billion-dollar business, SQL, multi-billion-dollar business. Many of the new businesses that we've created, that Microsoft's created over the last 10 years, really come from technologies that Microsoft Research has created. Now, obviously, the last year, there's been a lot of discussion about the work that we've been doing that have led to products like Kinect. And it's interesting because when I think of Kinect, I think of it as a real-time 3D computer vision technology. And interestingly enough, back in the late 1970s, that's what I did for my PhD thesis. I actually did a PhD thesis in 3D computer image understanding. This is an area, obviously, that the field of computer science has been working in for a very long time. But a couple of years ago, our product teams came to us, specifically the Xbox team, and asked us to help them to solve a really difficult and thorny problem, which was, how do we take sort of raw 3D information from a 3D camera and turn that into a reliable controller for a video game system that could operate in virtually any home, that could be used by virtually anyone, from small children to people in their 80s and 90s, that would give people the feeling of really being in an experience, in a game. And in some sense, the interesting part, the hard part of doing that wasn't getting the 3D information and figure out what to do with it. It was figure out, what did the 3D information actually mean? Who was standing in front of the system? What body parts were doing what? If you put your hand behind your back, and you move it back out again, is it the same hand, right? Or is it somebody else's hand that was behind your back that has just been pulled out? If your dog jumps in front of you, right? Was that part of you? What was that, right? If there's furniture that's right next to you, right? The underlying 3D information alone won't allow you to distinguish all those cases. So we really need to apply significant machine learning technology to be able to recognize rapidly what parts of the body were being looked at any given frame, what aspects of the system, of the human, were being recorded, which person were you interacting with at any given point in time. I mean, those were all the sort of critical parts of the process that really made that technology work. When you look at something like in the video that you saw earlier with PhotoFuse, I mean, PhotoFuse is an interesting technology. It's now sort of readily available, very easy to use by consumers. If you go back historically, that technology relates directly to research we published back in 2004 at SIGGRAPH, something called photomontage, that really showed how to take multiple images, quickly identify parts of multiple images of the same scene, and restitch them together to create a virtual scene that looked better than any individual scene. And so what you're seeing with PhotoFuse today is really the fruition of that early research that has been refined and eventually translated by the product teams into something that's easy to use and exciting, and solves an important problem for customers. Now, more and more, when you think about the way in which computing is changing, you're thinking about these kinds of technologies, machine learning technologies that allow computers to see, that allow computers to hear, much the same way that we see or hear, that allow computers to recognize different circumstances and different situations. We're giving computing and computers the senses that we have, and we're giving them the ability to interact and think in much the way that we do, but be able to do things on our behalf. So with Kinect, for example, we've given the computer the ability to recognize who's in the room, what are they doing, how are they moving, how are they interacting, what is it that they're trying to do in the context of a particular game or a particular application. In other places, we're taking the ability to recognize voice and to localize voice and allowing people to steer or manage their in this case, game console experience, again, through voice, or in the example of something such as the Ford Sync product, being able to control aspects of their vehicle and interact with their car. So we're giving computing more and more of an ability to do that type of interaction. Now, we're continuing to do a lot of research on how to continue to improve the way computers interact, how they see the world, and to think about the kinds of applications that can be built that support users in the tasks that they have. I'm going to show you just a few examples of this. And these are all examples that you'll be able to see in the TechFest public room that you're going to be going into after this talk. So these are all things that you're going to be able to see. Kind of think of this as a preview and give you a sense of what's going on. The first one is something called Mirage Blocks. And it's really a technology that lets you quickly capture and potentially interact with virtual objects. So can I show that video, please?
Hi, my name is Hervé Benko, and I'm a researcher here at Microsoft Research. Today I'll show you my newest demo called Mirage Blocks. Mirage Blocks is really a result of our research in spatial augmented reality, and we were investigating the way that you would interact with freehand gestures in space. So this particular demo showcases how you can instantaneously digitize or virtualize any physical object and then interact with it right on your tabletop. It's a single-user demo. That means that you actually have to use these 3D glasses that are just shutter glasses. The main idea here is that anything that you bring to the table is instantaneously digitized. In other words, any physical object that you bring up becomes virtually reflected on the table. So how does this look? Well, if you put your hands right in front, you actually see the reflection of the hands right there. You're seeing double images, but I'm seeing just a single stereoscopic image in my eyes. This actually means when you put an object down, such as Ernie here, Ernie is a good friend of mine, we can instantaneously capture it. And how do we capture? Well, there's a little button here on the side. If you press that, Ernie becomes virtual. So the physical representation of Ernie, we can move away. Now, the virtual representation behaves just like any other virtual object would. So you can do all the things that you're used to in CAD software, like rotation and movement. You can also do things that you cannot do to physical objects, like make the Ernie a lot bigger, or you can make the Ernie a lot smaller, so you can have a very little Ernie on the side. Let me show you how you can use this to actually build up a virtual castle just out of a couple physical blocks. So the grid just shows you the ground plane, and this is a mirroring line, so anything over here is going to be mirrored on the other side. What this gives us is opportunity to actually build up a little castle, a couple blocks here. And let's start with this base and let's capture them. That's our virtual representation there. Now we can move things down into the table, things that you actually cannot do with physical objects, but virtually it's totally fine, and build the next level. And what if we move it down just a little bit more? Maybe we can now build something that is not necessarily possible in real world, which is do things that gravity would defeat, but in here they work just fine, something like this. And here you have it. You have a little castle object that is just built up directly out of physical blocks. Well, this was Mirage Blocks demo. And I hope you're starting to see how we're researching these ways to bring the physical and digital virtual worlds together in a seamless manner.
And part of what's interesting about this is really the sense that increasingly we're going to be able to bring the three-dimensional physical world into the computer to be able to use and manipulate in much the way that, in the last, 10 years or so, we've brought photos and music and sound into our computers to be able to manipulate and interact with things. I mean, this is all, by the way, based on the Kinect camera behind the scenes there. This gives you a sense of the ability to now be able to quickly and easily and inexpensively capture three-dimensional images, make them part of something that you're working on, whether you're an architect or a CAD designer, someone who's trying to create a new product, or simply visualize something in a new way. Now I'm going to show you something else. Again, this also depends on 3D imaging and machine learning technology, but this is really a technology that tries to use those ideas and try to attack a different problem. In this case, it's a medical problem, and trying to support medical practitioners as they're working with radiological images. So I can see the next video, please.
I'm Criminisi, and I work in Microsoft Research in Cambridge. And today I'm going to talk about the InnerEye project that we've been working on for a few years now. The InnerEye project is about medical images and specifically about automatic analysis of medical images, extracting semantic information which is normally buried within the pixels of the image and making it available to doctors, and we will see in how many ways this information can be used. So here is the first demo. It is a radiological viewer. What you're looking at is CT scans. In this case, it's a single CT scan of a patient, and we can look at it from the front, from the side, from the top. And you should be able to recognize different structures like the liver, the kidneys, and the spine. Now, what the InnerEye project allows you to do is automatically figure out where all the major organs are. So I'm going to click on a button here which says Detect Organs. And in about a couple of seconds, the computer now knows where the heart is, where the liver is, and the spleen, and so on. And so if I'm a cardiologist and I'm only interested in the heart, what I do is I just click on the heart, and I get a nice optimized view of the heart on which I can do diagnosis. The image registration problem, although many people have worked on it for decades now, it is still a largely unsolved problem. And what we have here is a demo which shows how we address it. So we have two images taken at two different times of the same patient. This is the first and this is the second image. And for both images, our automatic anatomy detection algorithm has been run. So all that information is kept, inside the computer. And now that we have that information, we can align all the organs with one another. And so we obtain this view, the third view, which is more closely lined up with the middle view. And so now, when I move the cursor over, I can see the different structures in correspondence, and the kidneys or different structures appearing at the same time, or the pelvis, and so on.
What's interesting there is you're allowing the computer to rapidly analyze a large set of images, extract information that's pertinent to a particular technician or a particular doctor to look at a particular organ or component, and really speed the whole process of analysis. And what's interesting here too is that, again, many of the same basic ideas associated with machine learning, some of the image registration work that you might have seen, for example, in PhotoFuse, a lot of those same ideas, a lot of the same technologies are now here being applied to tackle a very, very, very different problem. Now, the third, again, you'll be able to see this in real time when you go into the demo room. The third and last video I'm going to show you is of some joint work between Microsoft, Intel, Mass General, and other partners, really trying to attack a problem of making it easier and faster to do colonoscopies, which I know is something that everybody really is very excited about. This technology actually will make it possibly much easier for a much larger number of people to be screened. So can I see the last video, please?
Hi, my name is Kurt Devlin. I'm an architect with Microsoft Developer and Platform Evangelism. And what I'd like to show you today is a demonstration of the results that were achieved by a collaboration with Massachusetts General Hospital, MS Research, Vectorform, and Intel. The problem space is colon cancer screening. Most people today do not get screened because it's an unpleasant process and it's invasive. The way that we do this, we create images from CT scans that eliminate all of that unpleasantness for the patient and make it possible for it to be as fast and convenient for the patient as it is for the doctor who does the diagnosis. Let me show you the demo and give you a sense of what it might be like for the radiologist to navigate through this image. What we've done is we've added natural coloring to the image as well as some unnatural coloring to highlight points of interest. As I use the multi-touch control, I can wander down through the interior of the colon looking for growths known as precancerous polyps. You don't have to be a trained radiologist to look at this image and realize the patient has polyps because the coloring that we use calls it to their attention. One of the important points about natural user interface is that it not only has to be visually very natural, but the the objects that you're manipulating also have to be moved in a very natural way. This is possible because of the GPU-based 3D volume rendering engine that was built by MS Research that allows the screen to be very, very sensitive to touch, and it can easily reorient the image in a way that makes it very natural for the radiologist to now look at this in a completely different mode of interactivity, and you see exactly what you want to see, exactly what you expect to see, because the engine is so fast and so performant and produces such high quality images. This helps improve the accuracy of the diagnosis and makes it an efficient way to navigate through images. We've done this because we wanted to be able to go from the CT scanner to real-time images in as quickly as possible and produce very high diagnostic quality images.
So there you see, really something that I think is remarkable because it was done over a relatively short period of time, where doctors came to us basically say, we have this problem, we don't have good solutions to it, and Microsoft Research, Microsoft, it's the broader company, Intel, the other partners involved, all got together, and over a relatively short period of time, were able to pull this together. What's interesting here is that a number of technologies are being shown. One thing he didn't really talk about, because it's kind of unpleasant, is the virtual elimination of the fecal matter. Right? So you're taking the contrast agent, but there's still fecal matter in your colon. You need to be able to virtually remove that from the images so that they're not part of what the doctor sees. That's an important component to that. The very fast volume rendering technology, again, that's something which you also saw in Antonio's criminal disease presentation on InnerEye earlier, which basically, again, shows off the notion of how do I be able to see this and manipulate it, interact with it in real time very rapidly. And then there's a lot of underlying machine learning technology for recognizing which parts of the images potentially represent polyps and should be highlighted to be able to direct a radiologist to areas that probably need the most visual attention from the radiologist. So I hope I've whetted your appetite a bit for the presentations that you're going to be seeing as you walk into the demo room in just a few minutes. Again, the goal of Microsoft Research is both to move the state-of-the-art forward in the technologies that we do our research in. We do that, I think, as well as anyone in the world. Secondly, to move our ideas, our technologies into products and have an impact. And if you look at the impact Microsoft Research has had on Microsoft today, it's really remarkable. I mean, it's allowed Microsoft to grow its revenues over the last 10 years by more than $35 billion on an annual basis. It's a huge impact, and something like Kinect is already a multi-billion-dollar business for the company in a very, very short period of time. So I hope I've given you a taste of what you can look for, what you can expect to see. I'll again welcome you to TechFest, and I hope you have a great time when you go to visit the demos. Thank you very much.